We're here at the south end plant room with the 3 banks of chillers. On my left and my right we have the condensers, and as I said there's 3 of these. We've got 3 fans on each section, protection guards on each of the units. The end of the condensers here we have a small control panel which just has a local isolator on, which allows you to isolate the whole of the condensers. Each one of the fans has its own isolator. Within this control panel, which can be opened with a standard utility key, there is MCBs for each one of the fans, which can be manually reset if needed. So now we're at the compressor end of the chillers. Following on, again, all these panels can be opened with a standard utility service key. So within inside these there is small control panels which can be operated and reset the chillers when needed. As I said, isolation switch here for the whole chiller, an emergency stop, and then a touchscreen controller for the operation and control of the chillers locally. Most of the operation takes place in the first floor plant room, which can control and repeats everything that you can see on this screen. These screens are primarily for the engineers' operations during service and maintenance. In here we have the pressurisation pumps for the cold and chill down here on the left, and we also have a hot glycol pressurisation pump down here, consisting of a header tank here which is for glycol mixing and glycol storage, which feeds these header tanks. We've now come inside to the ice rink, and again we're on the southwest side of the building, which we've come to the snow pit area. This is where the snow from the Olympia is cut and any waste snow is put. Inside here we have a stainless steel coil which is fed by the hot glycol pump that we previously saw outside in the pump room. We've now come down to the northwest side of the ice rink, just off the ice pad to my right, just to illustrate the vents down here that take in the air to keep the undercroft free of ice. It's highly important to keep these clean and free of any dirt and grime to make sure we can continue with a good airflow underneath the ice. We're now down at the south end of the ice rink pad itself, and I'm currently walking over the top of the header trench which houses all of the cold glycol pipes that run underneath the ice. The pipes come to the edge of the pad, and after that there is clear access for GRP panels to be lifted and safe access to be made into the header trench. This area is classed as a confined space and does therefore require a trained and qualified team to access. In the header trench there is 2 sump pumps for pumping away condensation and wastewater, along with 3 air fans to circulate the air underneath the ice to prevent permafrost. We're now stood underneath the air distribution socks, which are at high level, D-shaped. They run the full length of the rink and allow good air circulation and dehumidifying amongst the building in the main ice rink hall. These are fed from the main air handling plant, which is situated in the first floor plant room. Routine maintenance on these, they will require taking down and washing probably every 3 to 4 years, depending on use and conditions. Moving on, we now come past the entrance hatch for the motors, and we move on to the chilled glycol section, which houses a 300 kilowatt cooling coil for dehumidifying and condensing out any moisture into the air. This coil typically operates around a -1 inlet with a 3-degree outlet. Down below we have a glass U-trap, which is a good indication for moisture being removed out of the system. This, in certain conditions, will not run, but during the summer months it would constantly expect to see water, so it's a good maintenance to get into to make sure that's kept clean, just with a general bottle brush. All of the MCBs for the fans, controls, pumps can all be reset and looked from and monitored at from here. We also have our network switch down the bottom, which occasionally might need resetting, a PLC, which is the main controllers for the whole plant, and again network switch for remote access to the unit. So coming back to the main screen, we've got our 3 chiller options that we saw outside. So looking at these, we've got chiller 1, which is currently running at about 45 Hertz. Looking here, we have a demand speed and actual speed. We have the envelope status, which is OK, and its status is running. We have an enable and disabled for the plant upstairs, and a standby and on, which is a switch downstairs as well, but both switches can turn the plant on and off from this location.